everyone, welcome back to Little Code. Today let's practice a Hackerrank question, reverse shuffle merge. So this question comes from the interview preparation kit. So here we are given a string S, and this string is a combination of a single string A. So we will reverse this A string and shuffle this one, and then merge the reverse version and shuffle version of the A. And given this S, we want to find out the lexicographically smallest A. So what is the lexicographically smallest A? So imagine we have a string B, C, and the shuffle one of this one is, we can also have a B, C. So we want to compare the first index or the element in the first index in the string. So this is B and this is C. Since the B is smaller than C, so this one BC is the lexicographically smallest A. Here from the hints, so we can have three hints from the problem description. So the first hint is this one. So this A is a reversed version, right? So if we want to find out the original A, then we can iterate in the S from backwards. So that means we can get the normal order of the A. So that's one is backwards X. So we will iterate the S, but from the end of the S. The second thing is that we already know the S, it comes from two A's. So that means every character in the reverse version and the shuffle version of the A has the same frequency. So here I just have this one. So S, we can have it as a target. So that is the lexicographically smallest A. So that is a target one. Or it can also have another string. So every character we have to, for every character in S, we have to decide whether we want to put it in the target string or in another string. So the frequency in the target string and another string and the S can decide or help us to decide what category we want it to put in, whether in target or another. So here is the frequency, can also help. And the third hint is from the lexicographically smallest A. So think about if we have a possible A, so let's call it I, G, and then when iterating the S, the next incoming character is let's say is B. So in order to get the lexicographically smallest A, so we want to put, if it is possible, actually we want to put the B in the first character of the target string, right? We want to put B here. So if we can pop out the G and pop out the I and put them in another string and have the B in as the first character in the target string, so we can find out the possible lexicographically smallest A. So here are the three hints. So from the third hint, we know maybe we have to use a stack because we want to have a string append to the end of the we want to have a character append to the end of the string, and then maybe we also have to pop out the last character of the string and this one and append a new one. So here is a hint that we have to use a stack. And for the frequency, here we also maybe need to use a dictionary. Okay, so now let's use an example to elaborate. So E, G, G, and E, G, G. Okay, so the first thing is we want to check the character of each. We want to check the frequency of each character in the target string and another string and the overall string. So let's call it the limit. So that means for each character in target string and another string, it can at most have this limit of frequency. So here in the limit we have E of 1 and G of 2. So that comes from, in the overall we have a 2E. So for each string we will divide the 2E by 2, so we'll have just 1E and 2 G's. So this is a limit dictionary, and we want to have a target dictionary. And now they are all 0, right? Because we haven't put any character in the target. And another is also a 0. Okay, so now let's start from the end of the string. So first one is G. Okay, so here I forget to have a stack. So since the stack now is empty, so we don't have to considering popping any elements out of the stack. So we just have to decide we want to put this G in the target or another. So we will check the target string. So target string now G is 0 and the limit is 2, so it haven't reached his limit, so we can put that in the target string. So we can put that in G, put that in our stack, and also increase the target string, the frequency, by 1. Then goes to the next one. So next one is a G. Since the G is the same as the last element in the stack, that is also a G, so we don't have to consider popping out element from the stack. We just have to decide we want to put it in target or another. Okay, so here this one is 1. It's smaller than 2. So that means we can put it here, so it comes to 2, and we put G here. Okay, and then for the next one is E. For the E, yeah, this one E is smaller than the last element in the stack. It's smaller than G. It seems like we can popping out the G, right? But before that, we have also have to check if there are space for the G in another dictionary. So if we popping out this one, that means we want to put that in another dictionary, and we have to check. So this one is 0, so that has a room for this G. And also for this E, if we want to pop out this G, that means at the end we will put this E in the target string. So we also have to check if this E have a room in the target string, and that is 0, smaller than 1. So yes, we can put it in target string and pop out the G. So now let's pop out the G and decrease the target frequency by 1. So it comes to 1, and another one, it goes to 1. Okay. Before we put or append E here, the E in the end of the stack, we also want to check if we can further popping out the previous element, this G. Okay, so this G is, let's see, if we pop out the G, it has to goes to another string, and this one is 1, and the limit is 2, so that means we can popping out this G. Okay, so now we goes to 2. And for the target, we don't have any G now. And we pop out the G, and then we append the E here in our target string. So now the E goes to 1. Okay, so now let's go to the next G. So for the next G, first let me check, can we popping out the E by G? No, because the G is bigger than E. And so next thing is we have to decide we want it to put in the target string or another string. So this G, let's check here, the G is 0, so it still has space, so let it put it in the target string. So now it goes to 1, so we'll have append the G here, and now goes to the next G. So this G is the same as G, so we don't have to consider popping out elements from the stack. We just have to decide we want it to put in target or another. So in the target, the G is 1, and for the limit is 2. So yeah, we can put it here, so it goes to 2, and then we put the G in the target string, and then goes to this E. So for this E is smaller than the G, so maybe we can consider popping out elements of G and then put E here. But before that, we also have to check if we popping out the G, is there any room for the G in another string? But here the G is already 2, so that means we cannot popping out the G. There is no space for the G, so we cannot popping out it. Okay, so after that, we have to decide we want to put the E in the target string or another string. Okay, so for this E, let's check. In the target string, it is 1, and the limit is also a 1. So that means we cannot put it in the target string. So we can only put it in another string. So increase the E by 1. Okay, so, and then we have reached the beginning of the string. So that is our answer, EGG. For this question, the time complexity is okay. So we would like to produce this limit dictionary. So we will go through the S one time. So it is the S, and then after we have the limit dictionary, we will go backwards of the X and to the beginning of the S. So here we'll go another S, right? And then for each character S, we want to maybe have to pop out the elements in the stack. So it seems like a nested loop, but actually for each element in the stack, we will just add the elements once and popping out the elements also at once. So that is not actually a nested. So here, for this stack, at most it has the length of the S. So the popping maybe also takes X times. So here is the S. So the time complexity is actually just S. So the time complexity is the length of the S. And for space complexity, so for the space complexity, we'll have this limit dictionary and the target and another, so they are all lies in the length of the S. And for this stack is also the length of stack, also the length of the S. So the space complexity is also S, or the length of the S. Okay, now let's go to coding part. Okay, so let's start coding. So the first thing is we want to check the limit of each character. I mean the frequency. Okay, so I would like to use the default dictionary. Default dictionary. Okay. So here is a limit. And is a target. And another dictionary. And then here is a stack. So for each character in the S, we want to increase his frequency in limit. And then after that, we will go through the limit and divide each value by 2. Okay, so now let's start from the end of the string. So the character is S of I. So first thing, we want to check if we can popping out the elements in the stack. So we have to check if the stack is not empty. And then also the C is smaller than the last element in the stack or the top element in the stack. And we have to also check if there is a room for the top elements in the another dictionary. So if that is smaller than the limit, and if we can popping out the elements, that means we want to put the C in the stack, so in this target. So we also have to check if there is room for the C in the target. So if that's true, then we can popping out the stack. And after we popping out, then we will decrease that frequency in target by 1 and increase the frequency in another by 1. Okay. Okay, so now we have to decide we want to put the C in target or another. So we'll check if there is a room in the target. Okay, if that's true, then we can put in the stack. And then we will increase the frequency in the target by 1. Okay, so if not, that means we'll want to put that C in another. So we'll increase the frequency of another by 1. Okay, so and in the end we will return the elements in the stack. But we have to put it in a string, so I will use the join here. So that is a stack. Code. Okay, compilation error. Oh, so we forget a close parenthesis here, and then run again. Ah, here should be mine. So that's a 1 minus 1 minus 1. And this one. Okay. And submit. Okay, all the test case passed. Thanks for watching. Please like my video or subscribe my video. See you next time.